Welcome to qnawire.
All right, so I've kind of drawn a schematic here. We've got a spring of spring constant 250 newtons per meter, and a spring attached to this book, which is 2.5 kilograms, and it's compressed by 0.25 meters. And it's along this surface that has a coefficient of friction of 0.3. All right, and we want to know how far this book is going to fly. So this is a conservation of energy problem. So first of all, the potential energy in the spring, spring, is going to be equal to the kinetic energy of the book once it starts moving, and that is equal to the work that the surface has to do in the book to stop it from moving. Okay, so you can actually see we don't really even need this kinetic energy thing in here. We can just kind of forget about it. But it is conceptually nice to kind of remember that it's there. It's nice. So what we want to do now is write down the equations for the potential energy of the spring. So that's 1/2 kx squared. So 1/2 kx squared, and that's equal to the work that the surface is going to do. So the force of friction times the distance that it slides with that force of friction. So we're going to say this is the frictional force times the distance. Right. It's a little interesting here. We don't actually know the frictional force, so we're going to have to calculate that. So we know that the frictional force, let's do it over here. So this frictional force is equal to the coefficient of friction times the normal force. My high school teacher called this the fun equation. I thought that was pretty funny, so I kind of kept it. And then the normal force, remember, this is a horizontal surface, so this is just going to be equal and opposite to the force of gravity. So that's just mass times the acceleration of gravity. So that frictional force is just mu mg, right? Where m is the mass of the book, and then g is that 9.8 meters per second squared. Great, so we can substitute that in for that f there. And now what we really want to solve for is this d here. That's the distance it's going to slide before it stops. So let's do that now. We need to solve this equation for d. What we come out with is d is equal to, so this d is equal to 1/2 kx squared over mu mg. We got that just by putting the f in where that f goes and then solving for d. So remember, the k is 250 newtons per meter, the x is 0.25 meters, u is 0.3, m is 2.5 kilograms, and g is 9.8. So let's calculate out what that d is. And that's equal to 1.06 meters. So that's how far it'd slide. Yep,